say.
Error correcting codes. Or
Oh yeah, great. Okay, cool.
I think we can maybe wait for a few minutes for Joshi.
Have y'all been researching on that this week?
I've been rock climbing this week.
Oh, cool. Jay, do you have something in mind?
I've been looking through the holochain paper some. It's very abstract, so I'm starting to understand, the protocol, but I don't really understand, it's more like a roll your own consensus kind of a protocol.
This is interesting.
Yeah, yeah.
More like a Casper, right?
Well, Casper is a consensus protocol, but I mean, it's an abstraction. It's like a family of consensus. This one's more like describing everything else you need in a distributed system so that you can just choose any consensus based on what your needs are.
Oh, so this is not like a generalization of consensus. It's
it's kind of like a separate concept, and then you can use consensus also. But they do lay out this abstraction. That's kind of an interesting way to. I don't know if it's describing consensus or just describing blockchain, but they basically invert the responsibility for the hash chain from being a global hash chain to each individual stores their own hash chain, and each one can be different from everyone else's.
I heard something about that, but how is this at the end? How can you be sure in the information that you received from others? And
yeah,
it seems to me that there is even a greater problem than in Archain. You have like many more shards than in Archain. Does this make sense?
Yeah, you definitely could. I think it's really up to the application developer to solve that issue. Is their idea, and that each application is going to be a little bit different. Like if you're writing a Twitter, then you might care more about global posts and that those are consistent than if you're writing a private messenger app. And if you have group messages between 5 people, then you're much less likely to have sharding problems.
Yeah, the basic idea is that every program has a chain, and the program controls the chain. And any node that's running that application validates that program. The address on the DHT is the hash of the program itself. So you have to be running the same program and get the same result to validate the chain. But it's not a global chain. It's a chain just for that person, just for that app, just for that activity.
And for public transactions, so ones that you want other people to know beyond just your own hash chain, an application or a subgroup of people are connected by a distributed hash table that they share, and there's some consistent way of storing the replicated data. So if you make a transaction that you want other people to know about, then you basically push it to the hash table, and a few other people will store that data, and everyone should know about it and be able to query it on the hash table.
We ran an app in the Alpha Zero, a chat app, I assume it's a bit different now. That was over a year ago, I think. But essentially, they're programming with a actor model, and to do process, and the relation to the process model is through multi-phase commits. So you would use a multi-phase commit process to do transactions that were atomic.
This is really interesting that you mentioned multi-phase commits.
Wait, what do you guys mean by multi-phase commits?
To me, this is interesting in respect to error correcting codes, because exactly multi-phase commits, you're doing some communication to establish to correct the correct data that you want to store, like atomic.
Okay.
This is exactly what was Gregor explaining, that if you want to communicate some complicated structure with if you only have some atomic operations that are like a lower level structure, you must have additional communication.
Okay.
Hey, Tomislav, I wondered if we could hey, hello. I wondered if we could dig in on that example a little bit, because I think I get the big picture, but I wanted to be sure, because there was a part in the Casper Stand Up 84 where Vlad and Greg were going back and forth about that, and I wanted to see if I could pin it down. So if you just to tell me first of all, is this even a relevant example? So if I wanted to just communicate a character to you, if that's our alphabet, and I just say okay, it's X or whatever, then that's fine. That's one communication. But if I wanted to communicate a word to you, I would have to go not only tell you each letter, but I would have to tell you a priori something else, I'm about to tell you a 4-letter word, and then tell you each of the 4 letters. Does that sound kind of how that means about more structured data or something?
Yeah. And for me, this is very easy to understand, because I was working with electronics, and you have limitations when you want to build some communication between two devices, and this limitations is for example, how much wires do you have?
Yeah.
So you can atomically send some type of information to this other party, and if you have only 2 wires, you can just switch to a higher voltage and lower voltage. So if you want to send multiple bits of lower high voltage, you must do it repeatedly. You must do something, and on the other side you must recognize it. And I see this as communication, and I see it as a limitation, because if you want to send bytes, you must do this communication. And if you want to do some error checking, you must do some extended communication. And I see it in this very simplified form.
Yeah, that makes perfect sense. Okay. So I guess maybe I was trying to think of it as at too low of a level, because I was what I wasn't wrapping my head around was how do I take a step back to communicate that extra structure? It makes sense that I would have to communicate, in your example, if we've just got the 2 wires, basically 1 bit at a time. But what does the additional communication look like? Is the receiving device responding with ACKs, or reading back here's what I've got so far?
So I'm thinking just about the same way you're communicating the real message, in the same way you're doing some this other communication.
Yeah. Okay. Cool.
This is how I understand.
This might be a silly question, but if you're talking about the only method of communication that you have is exchanging 1 letter at a time, how do you even communicate that you're gonna tell somebody a 4-letter word?
That's the question I was
Yeah,
trying to
okay,
ask.
that's what I figured. That's why I wanted to ask it.
Yeah.
So you must have some synchrony constraints, and this now makes sense to me. But before I didn't think about that in this way. You know, I was using some existing protocols. So you buy some sensor, and this sensor speaks some SPI protocol, some other, I don't know. And if you want to program this yourself, you will have some. Either you will have some time constraints. You know, you must expect pulse in 100 milliseconds, for example, or you must detect some transition from 0 to 1 and 1 to 0, and this is really synchrony that you have, and this really can be the same in the consensus for example for Casanova that you mentioned, Joshi. This is the so in Casanova there is no fixed time. It's some transition that you are waiting, and after that you will have this guarantee of aliveness. But in which consensus? In this on Cardano, they have a fixed period of time that you are waiting, and after that.
Interesting. Yeah. Okay. So imagine we have like just a synchronized clock would work, right? Like if there were some beacon or like a lighthouse that lights up for a second and then dark for a second and then light for a second and then dark for a second, and then our communication protocol, like maybe you and I are positioned somewhere where we can like kind of hear each other if we yell. And so like every time the lighthouse lights up, I'm allowed to yell one letter. And then every time the lighthouse goes dark, you're allowed to yell one back if you want, optional in both directions. So I'm like trying to tell you some message. So like every time it lights up, I yell a letter. Every time it goes dark, I don't hear you say anything back. So I'm just like, all right, I guess I'm good to keep saying more letters. That's like an example of a synchronized clock?
Yeah. Exactly.
So how do you know then, like, does there have to be a special character for like end of message or something? Or like, how do you know when I'm done? Versus like, you know, I got assassinated and just stops talking, as opposed to like, that's the end of what I actually wanted to say.
I can give the real example, because I was looking at in these two sensors that I want to read the data, and they're pretty different. You know, this is the older one is just give me a first impulse, and I will spit out all of the I don't know 40 bytes. I don't care if you're a receiver or not. I will just spit it out in this a period for one is this long, and period for zero is this, and that's it. So this is not very friendly. But this other sensor, it's based on a clock. So he's accepting clock. Since he said with one wire you can give me clock, and when you push it to one, I will give you back on the other wire. I will give you back the result bit by bit. So giving the synchrony and gives you the data. Like a usual example of how different chips communicates between.
Okay. Yeah. So this is like I tell you one letter, and then you say like, okay, I'm ready for the next one, and then I tell you the next one, and you say, okay, go again.
Yeah.
Okay.
I didn't think about that in terms of consensus at all. But now I'm really surprised how this is like closely related.
I have a simple model, overly simple model of it. I mean, the error correcting code stuff is absolutely amazing in terms of applications using it to correct errors with minimum number of information. But in this case, I look at it more like virtual voting. Okay, the basic error correction is if you have two ones and a zero, you make it a one, and it's like voting. Okay, in that you have some algorithm may not be voting, but you're voting, and you're not using clock time at all. What you're using is activity. So if you have a certain amount of activity, you assume that you have as much information as you're going to get for the error correcting code, and you can't do any better. So it doesn't pay to stick around and wait for more messages. So it's sort of a generated clock rather than by activity, rather than a clock time.
And by activity, you mean new blocks, creating new blocks?
I'm talking about sending and receiving messages as activity.
Yeah. So in CBC Casper, those are the same thing, right? The messages that one sends are always new. Yeah.
New blocks, right?
Yeah.
And Josh, you mentioned a fixed set of validators and error correcting codes, and also this is interesting. Is this the rotation of validators also part of the error correcting codes?
Well, okay, so that was a really meta thought about what I was reading. So the Casper stand-up video, they talked about a couple different things, and only one of them was this error correcting codes thing. And one of the other things they talked about was how Vlad was saying, you guys are doing interesting stuff with validator bonding and unbonding that I think will probably work, but it is a little bit different than the stuff I've been writing up, which assumes a fixed validator set. And so I was just like, oh, that's interesting. Like Vlad's writing up maybe a simpler case that would be good to get it working first, and then we could move on and try to add in this mechanism of like validator rotating. And then my comment relating that to error correcting codes was that maybe we were doing the sort of a similar thing here, because Greg said something about like the error correcting code doesn't need to be fixed like from Genesis and forever. There's some method of updating it. And I think that's what he was doing with like the space calculus or that new calculus. And so the analogy I was drawing is like, I almost spilled something. The analogy I was drawing was like, I wonder if this is a situation kind of like validator rotation, where like there's a simpler case that we could try to get our intuitions based on, where we're not updating the code. We just have one we're fixed with. And then as an addition, just like validator rotation, we can think about like error correcting code changing with time. I don't even know if that's true. It was just like a thought that I had.
I understand, Greg, that we now already have like a functional consensus, but the problem is in performance, and this is where error correcting codes fits in.
Okay. Yeah, so I almost feel like
Is this really the case?
Oh yeah. What was that?
I'm thinking that am I understanding this correctly? Because is this only for performance, or?
I was thinking this was more about liveness than performance. Because
somehow the error correcting codes were giving us a notion of time. That's what I thought the whole point was.
Yeah, for liveness, definitely.
Yeah, because he was saying, the whole liveness thing heated up when Pyrofex published Casanova, and they were like, CBC Casper is not live and everything. And so Greg said in that Casper stand-up, like Casanova's way to fix it was to introduce that delta parameter, like an upper bound on, I think maybe round trips, or I don't remember, message receipt or something like that. And he was saying like, I would like to do this a little bit better, where we don't have to assume a fixed upper bound, you know, and we can do something like more organic or dynamic, or I don't even know what word, but like, you know, better.
Mhm.
So
What was
yeah,
the name
my question.
of the error correcting paper that we were looking at a few weeks ago?
What was that, Jay?
What was the name of the paper that we were looking at originally for error correcting codes?
Yeah. Good question. Oh, here it is.
Oh, you got it.
Yeah.
Oh, wait, no, maybe not. What I found was, oh, here it is. The title is Distributed Agreement and Its Relation with Error Correcting Codes. Here comes the link. Oh, yeah, that's it.
Nice. Yeah,
You win.
reached consensus.
Yeah, that's right. We reached consensus. So one thing I was going to say, and maybe that paper is answer to this, is I feel like there's a couple different ideas that some of them I understand in their entirety on, some of them I'm a little fuzzy on, but I don't necessarily see how they fit together. And so the ideas are like, one is this idea of error correcting codes, which I think I understand in the context of like, you know, data integrity and things like that. And then the second one is consensus, which, you know, you guys know my understanding of that, like in terms of Casper and the other algorithms we talked about. And then the third one that I really don't see how it fits in is that space calculus or whatever it is, where you can you need the like COM catalyst and location update and that kind of thing.
Yeah. So
I wasn't sure quite how those puzzle pieces fit together.
Yeah, I would like to know for this third part also. how because Greg was just saying, you know, we can use all of this stuff that we already have, like Y simulation and everything else. But I don't see how this is related.
Yeah.
So, you know, Greg brought that space calculus up during the introduction to design of computational calculus course. What was his motivation for bringing it up there? Was it in terms of consensus and Casper liveness, or did he have a different motivation? And now it's just kind of like bubbling up in this context too.
Yeah, I was wondering about that too. I wanted to go back and look at Jake's like RCL videos from around that time, but I didn't do it yet.
Yeah.
Yeah, he was trying to create a space, computation space, a multi-dimensional space that represented, well, process calculus. But what is it? The Sutter sphere or whatever, the idea of locality.
The anti-de Sitter space.
Anti-de Sitter space.
Mm-hmm.
You know, it's related to consensus,
Mm-hmm.
but also to problem solving more generally.
Yeah.
By creating, you know, by creating a locality that you can have, you know, I mean, we agree on the laws of physics primarily because we're all local to the planet Earth and we have a certain dimension. I think this whole error correcting code concept is related to that, in that it defines a locality or something in terms of these are the interactions that are that each sees as being their local environment, and they're going to agree with that rather than worry about global consensus right now.
Mm-hmm. Mm-hmm. So I remember one of the reasons he brought it up, or at least this, I don't know, maybe this is just something that was happening at around the same time. But with these like COM rules with different contexts, I remember him saying that you could translate between like different protocol layers using these different contexts just by viewing each protocol layer like as, one context, and then you can kind of like compose these COM rules in such a way that it was just like a natural translation between all the different protocol layers. I don't know if anybody remembers that discussion.
HTTP and TCP, for example.
Yeah, right. Exactly. Yeah.
Yeah, I totally remember that too. And I think the idea was basically like, we have many different protocols that can all communicate the same languages, but in different ways. And we can think about like whatever context we associated with this particular COM-K as being like the adapter cable or translator or however we think about it.
Yeah.
And where is this context? I'm thinking that we don't see it in directly in Rolling. Right? Or
yeah, I think it's literally not even the same calculus. Like it's a similar calculus that has many COM rules, and we just happen to be using the simpler row calc that only has, or another way to think of it is the COM rule that we use every time is the one where the context is just a whole. Like there's no additional stuff sent in.
Yeah, that's right.
Oh.
What kind of additional stuff?
So like for example, imagine a context that's like @nil send whole. So like whatever the message is that we were going to send is empty. And so now the COM rule associated with that context is whenever you have a send and a receive that come together on the same channel, that part's the same as before. Then you take the message that you sent, you jam it into this context, so it becomes the message in this new send, this @nil send whatever the old thing was. And now that whole new send, that @nil bang whatever, subs into the continuation in the same way that like just the message would have in the regular, more common row calc or PyCalc.
Okay. So it's like elevating it, like lifting it to a new context.
Mm-hmm.
Oh, I think he even used the word lift a couple times.
Huh. Yeah, I'm imagining like functors.
Yeah.
Right.
Yeah, probably.
Yeah, like the applicative functor has the lift and the mapping. It's kind of a similar context.
Yeah. Yeah, so I didn't really know where like the rubber hit the road on that. Like I didn't feel like I was able to yet think of a like super concrete example of like what the error correcting code might look like or how we might use it to establish time. Or I was almost trying to think of just like a toy example, like if we wanted to send messages to each other with a agreed upon error correcting code and somehow see if we could get a no time out of that. Like I don't know what that would look like.
But we don't have like some existing value that we have immediately. We will create this with the consensus.
Yeah. Say that one more time.
So we don't have any specific value that we want to agree. We will just.
Oh, I see.
Or are you meaning like some time is the value that we're trying to agree on?
Well, I'm thinking that if you have some fixed synchrony constraint, then this is okay. right? But if you want to have, if you don't want to have this fixed